Good day to y'all. We're going to show you the setup for the liquids lab. So here's the actual paper you should have got in class. If you didn't get in class, it's going to be an attachment to this Plus Portals file. And all you need to do for the pre-lab, all you need to do is answer these 8 questions here in the pre-lab section, pre-lab questions right here, and just answer them right here on the paper. That's what I'm going to come around and look for. Do you have all 8 of those completed on Monday morning? And then I'll stamp it if you got it. If you don't get the stamp. But then I'm going to show you on this video what each of these stations, what the setup is for each one. So station 1 is about finding the density of unknown objects. Let's show you what that looks like. Okay, so here we are at station 1. And at station 1, we've got 3 different materials we're going to try to identify, kind of like what we did in our graphing density thing, except now we've just got 3 unknown things. We're going to see if we can identify them based on their density. So that means we need to find their densities, right? Each one, you could find what its mass is. So we've got some extra little trays. We could put them on the scale, and we want to make sure it's zeroed first. And we could find what the mass of this sample is, right? The other part we need to know for density is to find its volume. So we've also got some graduated cylinders, and we're going to use the water displacement method because these have a weird shape to them. So I'd want to fill it up to a certain amount of water, and on our little liquids lab direction sheet, it kind of shows what we're looking for. The water might form a little curve on it called the meniscus. So when you are eye level with it, you're going to see a little bit of a curve. You want to measure where the bottom of that curve is. That's how much starting water you've got in there. I need to record what the volume of water is on my little table on that first sheet. And then I want to add this stuff to it. I need to be careful that when I drop it in there, remember there's water in there too, that water isn't splashing out. That would be a source of error. When I add it, I'm probably going to see a new water level afterwards. So I want to record that one too, where the meniscus is, if there's a meniscus. And the difference in those is going to be the volume of these objects. Now they're going to be probably pretty wet, so I want to roll them out, not back into their regular tray, but onto some paper, kind of dry them off a little bit so the next group doesn't have a gross mess and sources of their own. Think about why it would be important to get the mass before getting the volume, especially when we're using water here. And we'll do that with each of these materials. Okay, so once you've got the density of each one, we'll have a little table for you. You can check out the table, see which of these different items on here seems to match with the different densities. Here we are at the second station. At station 2, we've got an object. It's actually 2 objects, but we can treat them as one because they've got similar shapes. This object is kind of like a rectangular piece of metal, but it's got a hole drilled through it. So we're going to talk about in class how we can find the volume of such a shape. You can think about it on your own. But you want to find the weight of this thing in air, and you can do that using a spring scale. So I can just attach it to it, find how much it weighs in air, record that. And then I want to make a prediction about what's going to happen to the weight of this thing when I put it in water. We're eventually going to try and find what is its buoyant force while it's immersed in water. First, we want to find the volume of this thing. So you'll make some measurements. We've got a ruler here for you. Take some measurements on this thing and see if you can calculate what its volume is. And then you're going to have to go through some of those tough steps. Remember that when it's fully immersed, it's going to displace a volume equal to itself, water. And the weight of that water should tell you the buoyant force. You want to go through those steps to calculate the buoyant force on this first, and then you're going to actually measure the buoyant force and see what happens when I lower this thing into a tube full of water. Now, once it goes under the water, I don't have water here right now, but once it does, I'm going to take a reading on my spring scale up here, which I'm holding it with, and see what's the reading on the spring scale. How much does it weigh now that it's immersed in water? It might be different than what it weighed in air. In fact, we hope it is, because the difference between those two should be the buoyant force on it. Next, we're going to see, does that buoyant force change as I go deeper and deeper and deeper in the water? Now, remember that when we're measuring depth, I don't want to use the little markings on here. These are measurements of volume for how much water there is in here. Instead, I want to use a ruler to see how many meters am I below the surface of the water. Okay, and we're going to see if that buoyant force changes with depth. That was station 2. So once 2, we'll go to station 3. And they're probably hard for you to see on there, but there's little tiny holes, and they should be all pretty much facing the same direction so that when you fill it, it's going to leak. And you want to have this in the sink so that the leaky holes are facing kind of in towards the diagonal across the whole sink. So we've got a long way to spray. You're not making too big of a mess. So once you fill it up, you can have somebody fill this cup up with water and continue to keep the water level in the bottles at the same spot. And you're just going to observe, where do those spraying things go? Make a little sketch of them. Then it asks you to make some measurements, right? How far apart are those holes? Especially how far down are they from the surface of the water level? That would be a key thing. You also want to take some measurements on how far they actually seem to spray off. Which one seems to spray the most? And then you can theorize about why that is. Of course, once you finish with station 3, then you'll be all done. Now, you may not do these in order, 1, 2, 3. We'll have rotating groups, so some groups might start at 1, some will start at 2, some will start at 3, and we'll let you know when to switch. Good luck, enjoy your pre-lab, and we'll see you Monday.